Okay, so we were talking about some questions based on charge particle in combination of electric and magnetic field and things like that. So we will start with some revision questions. From magnetism. We'll move on to some questions from mechanics also, and mechanics will include something from gravitation. Okay, so this question we have basically based on geometrical path of a charged particle. In the XYZ system. So let's say we have a charged particle of charge plus Q and mass M. Now at time t equal to 0, the particle is projected from the origin. Origin over here with an initial velocity u of this kind of velocity inside a uniform magnetic field. So first of all, find its velocity at time t equal to this value. And secondly, find its position in terms of XYZ coordinates. And third, find its displacement of. So these three things you have to work out for this. But first of all, you have to understand the question itself, what kind of paths the particle will be, etc., from the given information. So just start with this. We will discuss about this question. You can see that it's a charged particle which is released in just a uniform magnetic field. No other information is given. That means we'll have to assume there's no gravitational field and there's no electric field present. Now, just by looking at the initial velocity vector and the magnetic field vector, you should be able to understand what kind of trajectory the particle will follow. So in fact, you can start by understanding what is the trajectory and what are the properties of the trajectory. Then you can come to the specific thing of, at these various times, what kind of velocity and displacement it will have. Okay, so to begin with, you can see that it is a helical path, okay, because you have a charged particle in a uniform field with velocity which is neither parallel nor perpendicular. You can understand here that this being the case, the trajectory of the particle would be helical, such that you can see that the perpendicular component of velocity here is v naught into 2 I cap plus 2 j cap. So it is 2 root 2 v naught in magnitude. Whereas the parallel component of velocity is v naught k cap. So it has a radius of curvature of the circular path as this. Uniform circular motion in the xy plane, and time period for the uniform circular motion in the, whereas it also has a pitch of parallel component of velocity into time period. So these are the various important parameters. So this will be inverse of this. Right. So now let us understand this thing geometrically first. So if we look at the motion strictly in the xy plane, where we have the uniform magnetic field coming out of the plane, because it's along k cap. So we can see that the charged particle at t equal to 0, it's here. And we can see that it's perpendicular component of initial velocity is like this. This is the v perpendicular. And of course, we have the uniform magnetic field, which is coming out of the plane. And we have the properties of the charged particle, Q and M, mass and charge. So the direction of magnetic force, you can see V cross B will be pointing in this sort of a direction. So the instantaneous magnetic force acting at t equal to 0 will be like this. Okay. So in the particle's trajectory, you can see that the circular motion part will be like this. It will be something like this. Say something like this. The center of curvature somewhere over here of the circular path. Okay, so roughly something like this. Whereas, as you know, it also has a component coming out of the plane. So this is the situation. Okay. So now, for example, we have all this data over here, time period and all this, we know. So let's come to the first part of the question. We want to find the velocity at this time. So the first part of the question is we want to find the velocity at t equal to pi m by qb, or that is equal to half the time period. So at half the time period, as far as the circular motion is concerned, the particle is here. It's at the opposite. This is where it is at t by 2. So its velocity vector will be looking like this as far as the perpendicular component is concerned. The parallel component will remain undisturbed. Okay. So at this particular time, the perpendicular component of velocity will become negative of its initial value, because the angular displacement is equal to pi, and the parallel component of velocity is unaffected. So the velocity at this time t by 2 will become v naught into minus 2 I cap minus 2 j cap plus k cap. So this should be your answer to the first part. So just this part alone you can do more directly also. You did not need to completely draw the diagram and all that. Just these formulae would have been enough. So I'm just minimizing this for you to take a